Alright guys, welcome to the pre-algebra video for 4.5. We are talking about the rules of exponents. Alright, so what I think would be good to talk about first is called the product of powers property. Now what does that say? Well, it means that in order to multiply powers with the same base, add their exponents. Okay, so what does that look like? Well, first of all, let's diagnose kind of what an exponent and a power and a base is, right? So if I had 4 cubed, what is that thing? Well, the whole thing is called a power. That is, of course, called the exponent, and the 4 is called the what? The base. Okay, so again, the property says to multiply powers with the same base, add the exponents, okay? So, for example, and we're talking about item number 1 here. If I had 4 cubed times 5 cubed, could I evaluate that using this property? Well, see, to multiply powers with the same base, add the exponents. So, well, see, this is a 5, that's a 4. Those don't have the same base, so I actually couldn't evaluate that using this product of powers property. But what if I was given, so right here, can't use property. But what if I was given 2 cubed times 2 to the 10th? And I said evaluate that. Well, evaluate, need to look at what's going on. Multiplication. So it's multiply. How do I multiply using this power? Well, I keep the same base, 2, and I add the exponents. So 3 and 10, 3 plus 10 gives you 13. So 2 cubed times 2 to the 10th is 2 to the 13th. What do you think about this one? 7 to the 9th times 7 to the 1st. Well, same base, so I keep the base of 7, add the exponents. 9 plus 1 is 10. Now what if I given you 7 to the 9th times 7? Well, hopefully you look at that and say, well, 7 and 7, those are the same base, but what's the exponent here? Well, it's actually an invisible exponent of 1, just like we had up there, okay? Same thing if I said, what's 5? How could you rewrite that using an exponent? You would say 5 to the 1. 6 would be 6 to the 1. Same thing, right? So, again, you would do the same thing as up here. Keep the base, which is 7. Add the exponents. 9 plus 1 is 10. And if I said leave it in an exponential form, you would just leave it as 7 to the 10th power. So I want you to pause the video and I want you to try this one. Okay, a to the 10th times a to the 4th times a to the negative 1st. Go ahead and take a second and try that. Okay. Alright, so hopefully you recognize that even though we're not dealing with numbers as our bases, that these are all the same base, right? A is the base of this power, A is the base of this power, A is the base of this whole power. So we know that we're going to keep our base, right? Now what do we do to those exponents if they have the same base? Add them. So I'm taking 10 plus 4 plus negative 1. Alright, so let's change the things up a little bit. 10 plus 4 plus a negative really means minus, right? And so now I go from left to right. 10 plus 4 is 14 minus 1. 14 minus 1 is, of course, 13. So what is our answer? A to the 13th power. Okay, the question becomes, what do I do in this situation if they say evaluate 3x times 5x to the 5th? Well, so let's think about what it's actually saying, right? 3x, we can write that as 3 times x, right? That's really what that means, but I'm just writing with multiplication there. Bring down this multiplication sign, times. 5x to the 5th really means 5 times x to the 5th power. Okay. Now I can use the commutative property of multiplication. Remember, commuting means moving. Okay, take the commuter train, you move. So I'm going to move the numbers next to each other and then the variable parts next to each other. So I'm going to rewrite this as 3 times 5, and I can only do this because everything's being multiplied in here, times x to the 5th. All right? So now I can evaluate 3 times 5, which of course gives me 15, and here x times x to the 5th. Well, remember, these have the same base, x and x. So I keep the base. And what do I do with the exponents? Well, I add them. Well, what is x's exponent? Remember, if there's no exponent present, it's technically the invisible 1. So now I add 1 to 5, and that gets me x to the 6th. So my last step would just be to simplify this up. I don't need that multiplication sign. I can just write it as 15x to the 6th power, and you're done. All right, so now we're on to the quotient of powers property. So quotient should make you think of what? Division, right? We're going to have division of some sort, and it's going to take the form of a fraction for the most part. So if I had a to the 10th divided by a to the 7th, what do you think I might do if someone said evaluate that or simplify that? Well, hopefully you recognize, oh, okay, here's a power and here's a power. Why are they powers? Because they have exponents. And the bases are the same. The base is a there and the base down there is a. So when I was multiplying things, such as like if I had a to the 10th times a to the 7th, remember I would keep the base and add the exponents. But here I'm dividing, so I'm going to do the opposite with the exponents. I'm going to subtract. Okay, so a to the 10th over a to the 7th. What I'm going to do is change this into this fraction. A to the 10th minus 7 over 1. Okay, so again, I'm subtracting the bottom exponent from the top. So 10 minus 7. 10 minus 7. And I keep it on, I keep the a on the top, right? So I put the, I take the denominator and replace it with a 1. I keep the base on the top and subtract the exponents. So then I get a to the 10 minus 7 is 3 over 1. And anything over 1 is really just itself, so I can just write this as a cubed, and I'd be done. So why don't you take a second, I want you to try this one. Take a minute, evaluate that, or simplify it, see what you get, and then we'll keep on moving. Alright, so hopefully you recognize that, these are both powers, because they both have exponents, and they have the same base. So I'm going to take the base and write it on top, and then I'm going to take the exponents and subtract the bottom from the top. So it would be like saying 8 minus 3, and I put that all over 1. And then I say, well, what's 8 minus 3? Well, that'd be like saying 6 to the 8 minus 3 is 5 over 1. And again, anything over itself is just itself. Or I'm sorry, anything over 1 is itself. So I can just rewrite this as 6 to the 5th. I do not need the 1 in the denominator. All right, so what about something like this, though? What about something like that? 0.05 to the 10th over 0.05 to the 9th power. How about that? Well, it's the same thing. It doesn't really matter if it's a decimal or not. They both of these powers have the same base of 0.05. So again, write 0.05 on top, then take the top exponent 10, subtract from it the bottom exponent, which is 9, put the whole thing over 1. 0.05 to the 10 minus 9, well, that's like saying 0.05, 10 minus 9 is 1 over 1. And again, anything over 1 is just itself, so I can just rewrite this as 0.05 to the first power. And in this case, I can simplify it even a little more because I don't need an exponent of 1, right? If I said write the number 5, you wouldn't write 5 to the first, right? You would just write 5. So we're doing the same thing here. Just get rid of the exponent of 1, write your final answer as 0.05, and you'd be done. Well, how about something like this, though? All right, 4x to the 8th over 10x squared. Well, let's see. If I'm evaluating this, okay, the directions here would be evaluate or maybe simplify. Well, let's think. I have a 4 over a 10. All right, well, there's a fraction I know how to deal with, 4 over 10. I can simplify that fraction and make it, well, let's see, 4 over 10. If I divide that by 2 and divide that by 2, that would give me 2 over 5. So I'll rewrite this as 2 over 5 to begin with. Now, so I've dealt with that, but let's deal with the x to the 8th over x squared. Well, let's see. Same bases here, So I write the x on the top, and then I take the 8 minus the 2, again, 8 came from there, the 2 came from there, and I put that over 1. So really what that means is on the bottom I could write times 1, but of course, do I really need that times 1 there? No, I don't. We can just leave it for now. All right, so let's rewrite this even a little more. 2 over the 5, can't simplify that, right? And on the bottom I have 5 times 1, which is just 5. So I'm back to just having 2 over 5. X to the 8 minus 2, that's like saying x to the 6th power. And am I done? I am. Can't simplify it any further. I am finished. All right, so let's do this one last though, okay? So this is our last one. If they say evaluate this or simplify that, what do you think you'd do? Well, I hope you would look at it and say, you know what, I know I need to obey order of operations when I'm given an expression, okay? And the first thing I see here is a grouping symbol, which is a fraction bar, and that's the first thing I need to deal with in order of operations, right? GEMDAS, grouping symbols, is the first thing. So what does that mean? Well, that means I need to do what's on top first, then what's on bottom, and then worry about relating the two. So on top, I have a 4y squared times a 3y to the 12th. Well, I know that I can rewrite that as 4 times y squared times 3 times y to the 12th. Okay, and I'll put a fraction bar there. I'll just rewrite the 8y for now. Commutative property of multiplication says I can move things around. I can get the numbers next to themselves. So I could rewrite this as 4 times 3. So I've moved that and moved that. And now I can take that times the y squared times the y to the 12th. So I've moved things around on top. Do I really have to? Not really. It's just kind of helpful. Again, this is all over 8y, not touching the bottom yet. Keep on moving here. And you get, well, let's see, 4 times 3 would give me 12. So I've dealt with that much. And then y to the 2nd times y to the 12th. Well, those are powers with the same base of y. And so what do I do to those exponents when I'm multiplying them? Okay, well, I'm going to add, right? If I have y to the 2nd times y to the 12th, it's like saying y to the 2 plus 12, which is y to the 14th. And again, that's all over 8y. So, is there anything left to operate on the top? Is there any more like, multiplication or division just up here? No. Now, do I need to do anything to the bottom? Like, do I need to take 8y times anything down here? No. So now I can relate the two. And I can say, all right, well, 12 over 8. I can simplify that fraction. Let's see, 12 eighths. I could divide that by 4 and divide that by 4, keeping all things equivalent. 12 divided by 4 is 3. 8 divided by 4 is 2. Let's rewrite this as, instead of 12 over 8, 3 over 2. Now how about the y to the 14th over y? Well, these are both powers, right? And it doesn't look like this guy has an exponent, but remember he has an invisible exponent of what? 1. And so y to the 14th over y to the 1st, that part right there is like saying y to the 14th minus 1. Which becomes y to the 13th. And where does that y to the 13th go? Well, it's on top, and we're going to get to this in a couple units, but the reason he's going to go on top is because his exponent is positive. So I'll write that y to the 13th up there, and you know what? You are done. You are done with that problem. There's nothing more to simplify. You've evaluated with all the exponents, and you're done. So 3y to the 13th over 2 would be your answer. Alright guys, that's all I have for you. That is a little more of a complicated video, so please go back and watch it if you're unclear. And of course, I look forward to seeing you guys in class talking more about this.